Once you understand what the register is in the general CPU architecture, now let's dive into more about the general purpose register in ARM version 8 architecture. First, let's take a look at the general purpose register in the kernel log. As you can see, this red box contains a set of general purpose register. It starts with X0, X1, X2, and X29, and X30 will be the general purpose register. All of the registers inside this red box are the general purpose register. As you can see, any of the temporal data in the function can be stored using any of the general and purpose register. Now, let's look at the part of reference manual of the ARM version 8 architecture that describes the general purpose register. As you can see, the ARM version 8 architecture in the 64-bit environment define the 31 general purpose register. As you can see, X0 to X30 are the general purpose register. But as you can see, there is another way to specify the general purpose register. That is W0 to W30. But as for WN register, that is W0 to W30 register, it only contains 32 bits of the XN register. For example, as for W0 register, W0 register has the 32 bit from 0 bit to 31 bit of X0 register. If you look into the assembly instruction and using the disassembler, you're going to see that some of the general purpose register could be specified as W0 or W1, W2, and so on. So if you look at the W0 or W1, that is kind of registered in any of the assembly instruction, and this is the you can consider, and this is the way to specify the general purpose register that contains 32-bit size of the data. Now that you got to know about the general purpose register in ARM version 8 architecture, so let's look at example assembly instruction in the slide. That this is the one of the label in Linux kernel. The name of the label is CPU switch 2. This label is responsible for performing that context switching. But as you can see, every assembly instruction is organized with any of the general purpose register. As for add assembly instruction, the two operand X0, X10 are operand. What I mean is that it is used as the input for this assembly instruction. Result data of this assembly instruction will be stored onto X8 register because X8 register is destination register. But as for this assembly instruction, the value of the SP register is copied to X9 register. And as for this assembly instruction, value of the X19, X20 is stored onto this target memory address. As for this assembly instruction, and the data at this target address is loaded onto this register. The X19, X20 registers could be considered the general purpose register. So once you understand any of assembly instruction, you got to know that general purpose register could be input to any of the assembly instruction and most of the assembly instruction, and it can store the resulting data onto any of general purpose register. So in summary, general purpose register could be used in any of assembly instruction in ARM version 8 architecture. Now we got to know about the general purpose register in ARM version 8 architecture. Let's explore the special register in ARM version 8 architecture.